如果想多听例题的话，就是TA 课去那个 TA 课 ，OK 吗 ？So we are in this section and in this hour from now to 4 p.m. we will work on two special types of rigid bodies. We call them two force body and free force body. Two force body in Chinese is this one. And naturally, free force body is this one. I will come to this later on. So, and first of all, what are two force bodies? Two force body has two. The definition has two parts. So first of all is no couples act on the body. And the second thing is external forces act on 2 points of the body. Remember, it does not mean 2 forces. It means please write this down and I will explain in a minute. Instead, take the time to write them down. So in this problem, and of course in two force bodies, all forces act on 2 points of the body, and it can be of course in this problem we have 2 forces, but we can have 3 forces and we still have a 2 force body. For example, if we have F1 here, and then we have sorry, I should use another color. We have F1 here, and we have F2 here, and we have F3 here, for example. For example, F1, F2, and F2A and F2B. We have 3 forces acting on a body, but these forces act on 2 points of the body because F2A and F2B, both of them act on point B. So we count this as 2 force body, not 3 force, okay? This acts on 2 points of the body. But we can have more than 2 forces. It's okay. It's okay. So for 2 force bodies, we can have more than 2 forces, but all of them act on 2 points of the body. It's okay. Now, and so we we work on the simple example of having F1 and F2, and let's get some. Let's see what happens. So we have suppose because which body is in equilibrium, and so we need to satisfy these two equalities. So summation F equals 0 and summation M equal to 0. Now, summation F equal to 0, it means that F1 is equal to negative of F2, right? Because this one goes to the left-hand side downwards, and this one should go to the right-hand side upwards. This is F equal to summation F equal to 0. Now, and summation M equal to 0, so we take any point as a reference point. For example, we take point A as a reference point. So we take point A as a reference point, and it means that because F1 is acting on point A, so this one M equals 0, because this one is R plus F equals to M equals 0. So this one, the moments of this F2 about point A needs to be 0 as well. So this one is the moment of F2 about point A. It needs to be 0 as well. Let me show you a counter example of this one. Oh, sorry. Counter example is for example, we have these two forces. We have for example, we have F2 prime and F1 prime. F1 prime should be this direction, right? For example, we have this one. For example, we have this one, and of course, these two forces satisfy summation F equal to 0, right? This one going to the left-hand side downwards, and this going to the right-hand side upwards. And now, for summation M, for example, we take a point A as an example. That is the moment arm, and then this is the force as R plus F, and this theta, and this one does not equal to 0. So this is not in equilibrium. It's okay. So it means that this one does not work. So the only way on a two force body is that the total force on point A and total force on point B, they are equal magnitude, of the same magnitude, and they have the same line of action, and this line of action is through AB and opposite axes. The magnitude are the same. F1 and F2 are the same magnitude, and the line of action needs to be the same, which is through AB. And they are opposite axes. It means the direction of them are opposite to each other. Remember this one for this one, and for this one it is summation M does not equal 0. It's okay. So this is two force body. Now we come to take your time to write it down. Okay, so we come to oh, sorry, okay, this is I made one more. This is the same one. And now we come to free force body. So we come to free force bodies. And is that anybody wants some more time to write that down? So I suppose it's okay. So we come to free force bodies. And suppose F1, F2, and F3 are not parallel to each other. I think most of the case is true. So we have something like this. There's something like this. Now we have in rigid bodies we have something called principle of transmissibility, which means this force can be moved to the front or to the back, right, along the same line of action. It can move for this force, it can move to the front or to the back, right? So in this case, we move this F2, we move it to the front. We move it to point D. And for F1, we do the same thing and we move it to the back. And we also move it to point D. It's okay. So we can say F2, line of action. Lines of action of F1 is AD, and the line of action of F2 is BD. It's okay. And D is the intersect of line of actions. So we come to the next point. And please take the time to write that down. And always 1 minute. On the left, we have a free force body. That means all the forces act on 3 points on the body. Okay, act on 3 points of the body. And now, on the right hand side, is it a free force body or two force body? Two force body, okay? Two force body and two force bodies. And the 2 points are point C and D, right? Point C is the force angle of point C is F3, and point D is F1 plus F2. So from what we learned from two force body, that means this one F3 has the line of action CD. And then we put it here. F3 is the line of action of F3 is CD. So what do we know from here? It means, okay, look, all lines of action of all three forces goes to point P. Lines of action, all forces go through point P. So in free force bodies, it means lines of action of F1, F2, and F3 intersect at the same point. Please break them down and I'll give you some time. Now, and this is not. And let me emphasize this. Because if a free, because for any free force body, and because you may ask if sometimes you may ask would this happen, like the free lines of action will go like this. Sometimes because if we draw some forces and sometimes the free lines of action will be like this, right? They do not intersect at the same point. And this rule tells us that this will not happen, okay? the phase on the left will not happen. That means all three lines of action, will go through the same point. It's okay. So it was. So you may ask whether these three lines of action will form a triangle in the middle. No. This will not happen. They will intersect at the same point. It's okay. And TA will show you some example on how to use this in problems. And of course, TA will show you some easy examples, and I will show you some difficult ones. And after you have write this sample to the next page, page 42. So, can anybody help me explain what do we do? What should we do on page 42? You can, of course, you can say it in Chinese if you want to. The problem on page 42. So, anybody want to explain what's happening on page 42? So, and of course, there are no numbers in this question. The only number is really equal to 0, right? That's the only number, and all others are symbols, and it looks like very difficult. And but it is not as difficult as you think. So let's go through the question. Color is it means this one. It can move free along the vertical rod. Okay. And the constant of the spring is and the spring is unstretched when the value to the 0. And the last thing is derived is this way. Satisfy is in engineering. Satisfy is so I think. Are there any words that you don't know? Any other words that you don't know? Now, because we have the word equilibrium, it means we have summation m equal to 0, right? And that means we need to draw the free-body diagram. We draw the free-body diagram of here we draw the free-body diagram of the column. Point B. And we can define, let's define x and y direction. Now, what are the forces acting on the collar? How many, are there any forces or couples or forces and moments acting on the collar? First of all, we have weight is W. We have the collar, the base of the collar is W. So we have W here. Next, this collar can move freely along the vertical rod, so it can move freely along. It can move up and down freely, so it can move up and down. Can it move left and right? No. So we have a force to the going to the right. So and let's write it like this. And remember, in the 2D problem, we have when we talk about rigid bodies, we talk about movement up and down, vertical movement, horizontal movement, and we have rotation. Remember, for rigid bodies, we have three things: going up and down, going left and right, and we have rotation. So can it rotate? No. So we have M. So what else do we have? We have the spring here. We have the spring here, and let's make it simple. And we say we have a spring force T here. And the angle theta is given. The angle theta is we don't know the value, but we know it is equal to theta. So we got theta here. Okay, and this is our free body diagram. Okay, now I think we have only let me see, and so after we draw this free body diagram, we can write summation f equal to 0. And summation m equal to 0. Okay. Now we have and for summation m equal to 0, we have three forces. They all act on the same point. P. This is T, R, and W. Right? Divide them all. And for summation m equal to 0, how many? If we take the point of reference as point P, we only have one moment. So this one equal to M. So M equal to 0. This is a very good example that sometimes you know that M equal to 0, but you still need to write it on the free body diagram. Okay? Because after some calculations, we know M equal to 0, but we still need to draw it on the free body diagram because this thing cannot rotate. It means we have an M here. Of course, after calculations, we know M equal to 0, but this is another thing. Okay. So I think I will continue working on this on Thursday. I will continue working on this on Thursday, and